4.4 number 11, we are going to calculate this limit when x is approaching to pi over 2 plus cosine x over 1 minus sine x. You always plug in this number into this function here. Cosine of pi over 2 is equal to 0 over 1 minus sine of pi over 2 is 1. 1 minus 1 is 0. So in this case, it's indeed 0 over 0. So we can use the L'Hopital's rule. L'Hopital's rule, okay. That means I'm going to differentiate the numerator and then differentiate the denominator separately. This is not quotient rule. This is L'Hopital's rule. Take the derivative of the top, divide by the derivative of the bottom. Alright, so we are going to have the limit when x is approaching to pi over 2 plus. On the numerator, derivative of cosine x is just negative sine x. And the derivative of the bottom, derivative of 1 is 0. Derivative of negative sine, let me bring down the negative first. And then derivative of sine x is cosine x. And notice that, let us simplify this expression first. This is the same as taking the limit when x is approaching to pi over 2 plus negative cancels to be positive. Sine x over cosine x is the tangent x function. So the question is, what's the limit when x is approaching to pi over 2 plus of tangent x? Well, let me do it this way. Let's look at the graph. So let's look at the graph of tangent x. And we should know that it has vertical asymptote at negative pi over 2 and also positive pi over 2. So like this, right? And then it has a lot more vertical asymptotes. And the graph of tangent x is going to look like this, right? You just go like this, and then it goes like this, right? So now if you can think about in terms of the graph, you don't need to do anything crazy with the tangent x. When x is pi over 2 plus, that means you are on the right hand side, a little bit to the right hand side of pi over 2. And notice that the function is approaching negative infinity because it's shooting straight down. So this limit is equal to negative infinity. So in another word, the original limit, it's also going to be negative infinity because of this.